And now that we've seen how the web works in very broad strokes, it's time to look at the vulnerabilities and the ways to attack it. I'm going to look at a variety of attacks against authentication, authorization, ways to inject commands, get access to client-side information, use man-in-the-middle attacks, and attacks against HTTP protocol implementations. But first, let's have a look at the first item on our list, attacks against authentication. Okay. And the question we're asking is, which is the best way to authenticate web users? And we've seen a number of different ways in which we could authenticate web users. We can use the IP address to maybe only allow specific IP addresses access to certain websites, and we've seen problems with that. One of the problems that we saw with with IP-based authentication is that you can spoof the source of a TCP connection. This is what we've been doing in previous videos. But there are other problems also. There may be multiple users behind a single IP address in the case of network address translators. Likewise, there could be a single user who has multiple IP addresses. In the case of a DHCP server that parcels out a new IP address over time. So IP address-based authentication is problematic. What about HTTP-based authentication? And we've seen that there are two basic schemes and that's an unfortunate choice of words. There are two schemes in which you can do authentication in HTTP. There's the basic scheme and there's the digest scheme. And the problem with the digest scheme is that it's nice, but there are so many options that are not consistently implemented in browsers and servers. And it's adding a lot of complexity at the application level that makes it hard to scale. And if you want to know more about that, have a look at this URL on the slide. Okay, so digest scheme is somewhat problematic, but the basic scheme works reasonably well, right? And as long as you use secure connections, right, encrypted connections, then it's perhaps not such a problem if the username and password are sent to the server side. But still, it's not the most convenient or secure by design solution. What about certificates? Certificates are explicitly designed to make this more secure, and they're supported by almost every server, every organization that you care to think about. Now, certificates are really nice as long as there's some authority that you trust that can vouch for the validity of a particular certificate. That certificate will prove to the remote party that you are who you are, and this is cryptographically secured from that moment onward because you can use those keys. I will talk about the exact details of these certificates later, but so certificates help you in authenticating remote parties, but it's really only for the server side. Very few individual users have certificates or would know what to do with them. Okay. So, and then the really basic schemes that use forms or URL rewriting are problematic because you can actually have this information, these credentials, sent out in the clear, and then they might be eavesdropped. So let's, as a first example, look at the most basic authentication scheme, not basic in the HTTP implementation sense of the word, but a really simple authentication scheme where we use forms to send a username and password over an SSL protected channel, so that's secure in that sense, to a server-side application. What the server side would have to do is verify these credentials by checking it maybe against some backend database, and then generate some authenticator, some value that is then sent to the client and used in all subsequent communication between the client and the server, right? So the client will always send this authenticator in all subsequent communication. So typically this is a cookie which is sent as part of the header. Okay, so here we have a cookie where the authentication value is John Doe Blue Dog, and here it indicates the secure flag is set. So that means that this cookie, and this is a very good thing, can only be sent over a secure connection, over an HTTPS session. Okay, so that's great. And next time the browser will contact the same server, it will also include that authenticator. In this case, it will, for instance, have the cookie set, and the authentication is performed using this value. Now, this is in principle not a bad scheme, but there are some issues still, right? So first of all, the authenticators are reasonably guessable, so they're predictable. If you just have some username password or so, or some names that could be guessed with dictionaries. So you'd ideally have the authenticators be not predictable, and you should also ideally have them not reusable across sessions. So a one-time authenticator is more secure than something that lives for a long time. So perhaps a better authentication scheme would be to generate some random value and then store that random value on the server side, part of the other information about the client. Okay. Now, some languages, such as PHP, have explicit support for this. Now, that's still not the end of the story, because if you want to have even more secure authentication, then you would use ideally multiple factors. So multi-factor authentication uses the fact that there are different things that you can use to authenticate. Right? Maybe something that you remember, something that you know, a username and a password, and hopefully the attacker doesn't know the password. That's one factor, and it's secure-ish. It's more secure than no factor authentication, because at least it makes the attacker have to brute force the password or whatever it has to do, or steal it from you. But that could actually happen. So maybe we want to use an additional factor, maybe something that we own, right? So if we go to an ATM machine, we do not just use our PIN code, but we also use something that we own, our bank card in this particular case. That's a second factor. We can also use a third factor. For instance, maybe the iris scan or fingerprints, something that we are, right? Something that we know, something that we own, and something that we are. Multi-factor authentication. Often this is made on the web. This is much shorter. It's a two-factor authentication scheme where you log in with a username and password, and then there is a second factor authentication. So the server that you logged into, maybe your bank, where you try to do a bank transfer, will send you some confirmation authenticator to a one-time password to a second factor, say a separate device. This could be your mobile phone, for instance. And then on that mobile phone, you have a look at the transaction details of the transaction that you just initiated on the web. And if the transaction details are indeed the same, so it's 100 euros to that same recipient, then and you trust that this is exactly what you want to do, then you actually use that one-time password, that authenticator, typed into your browser on your PC perhaps, and transfer that to the server, and the server will then complete the transaction. So you're having these two factors. But the security of that scheme depends very much on these two factors being separate. If these two factors are indeed easily compromised by the same attack, you don't have two factors anymore. It's a single factor. Okay. So this is becoming more and more of an issue, for instance, in the mobile world. So where all the entire transaction is set up from the mobile, right? So then you have the bank application that's where you type in your username and password, and then the second factor. So the second factor might be an SMS text message sent to your mobile phone. But if your mobile phone is compromised, totally compromised, right? So the operating system is compromised, for instance. It's very easy for an attacker to obtain that second factor, obtain the one-time password. So if there's no isolation between the two factors, it becomes more problematic. And what we saw already in the earlier days, right? So this is 2014 when we did some research into what was then the most dangerous malware in terms of the damage it caused economically, financially, people. The Zeus malware. It had this malware that was active in your browser on your laptop or your PC, and it would try to do bank transfers for you. So it would try to transfer money using your internet banking. functionality. And this became problematic with with two-factor authentication, because the second factor was your mobile phone. And already in those days, the most prevalent pieces of malware would then develop their counterparts for mobile phones. So after infecting your PC, they would also try to infect your mobile phone. Okay, and this was done in a really lame way. But once they had control over both factors, they could still initiate bank transfers, okay, and steal your money. So, for instance, the Game Over Zeus malware, which is the most dangerous one that was active at the time, Game Over Zeus, had its counterpart, which was called Zeus in the mobile, Zitmo. Likewise, the SpyEye malware had its mobile counterpart called Spitmo, SpyEye in the mobile. So already in those days, it was happening. Now, a couple of years ago, we did some research into two-factor authentication. You can still look at the paper. It's interesting if you're interested in this sort of thing, where the title of the paper is "How Google Killed Two-Factor Authentication on Mobile Phones" or so. Anyway, it was published at Financial Crypto, and what we show there is that nowadays the integration of the mobile world and the PC world is so extreme that once you compromise somebody's browser on their laptop, you also own their phone automatically, because nowadays you can push apps to your mobile phone from the browser in your PC. As long as you're able to and you own the browser, right? So this is trivial for you. You're able to get a session with Google. You can push these apps into the mobile phone, and even with some clever tricks, you can activate these apps so that whenever you do a transfer, a transaction, and the server sends an SMS text message to the mobile phone, the attacker has an app running on that mobile phone, right? Because it pushed that app there, and that app is able to intercept that SMS text message, the one-time password, and send it to the attacker. So this is, turning the two-factor authentication into what is essentially, again, a one-factor. Now, like I said, if you're interested in that, have a look at that paper, How Google Killed Two-Factor Authentication. Okay, some caveats on authenticators. One problem that you may have is that the authenticator that you are using leaks via the referrer field. And just to remind everyone, what the referrer field is, you have a page which contains some links, and that link, so this is the referring page, and that link, if you click that, you go to a different server, and part of the referrer field, the referrer field indicates where you were coming from. Okay, so let's have a look. You have a user accessing a page foo.com with some, there's a bunch of links there, and it went there with, some authenticator. Okay. Now, on that page, there's a link to another site, bar.com. And if you now click on this link, the referrer field will contain an indication of where you were coming from with the URL that you were using, and that happens to be the URL that contained an authenticator. Okay. In this way, the referrer field, the referrer header, may leak this really sensitive information. You don't want to do that. There are other issues with referrer fields. So some websites use the referrer field to protect some content that is interesting potentially for users, and make it only available after you've visited some landing page. And the idea is, for instance, that you have some icons, some images, or so that the user might want to access, and you want to only give the user access after they visited the landing page, where they maybe were shown some advertisement or other things that generate income for you as a service provider, as a content provider. And And what the problem, and you can use the referrer field to do so, right? So only if your referrer field has the right value coming from that landing page, you allow access to the images. Now, this is problematic when this referrer field becomes known, and an attacker simply creates these referrer fields manually, right? So if you acquire knowledge of these approved referrers, you can use that information to gain free access to the material. So there's clearly issues with referrer fields, and you have to be very careful how to use them. You cannot outlaw them altogether because they're also, legitimate users of referrer headers. So what can you do? Well, it's tricky, and if you want to know the details of this, you should probably look up the background information on this from Mozilla or some other sites. But there are referrer policies that you can set. For instance, in the server or in the HTML tags, you can decide what is and what is not allowed with referrer fields. Moreover, there are ways to suppress referrer fields. So there are some policies that already exist on the referrer field that will make sure that some interactions will not include the referrer field. For instance, a referrer header is not sent by a browser if the resource, the referring resource, is a local file or a data URI. Likewise, and this is perhaps more interesting still, an unsecured HTTP request is used, right? So an unsecured HTTP request is used, a regular HTTP connection to a server, and the referring page, so where you were coming from, is secured with HTTPS. Okay, so you're coming from an HTTPS site and you're going to an HTTP site, then there is never any referrer field transfer. Okay, so those are things that you can use. So if you just use the secure connections, that's probably a good thing, right? So that helps you protect against these kind of vulnerabilities. All right. Some other things about authenticators. Now, I think I already mentioned this, but authenticators should not be long-lived. The longer they live, the easier they become for an attacker to guess, to use, and you have to be a little bit careful with how you interpret this. Right? For instance, it may be very attractive to think of the expiration date in cookies as a secure way of enforcing this, but the expiration date of the cookie is not enforced by the server at all. It's enforced by the browser. And that means that if an attacker gets access to the cookie file, right? So if the request comes from the attacker has access to the cookie file, the attacker can simply modify this expiration date. Okay? So what you need to do is either store the expiration date at the server side, or you include them in a cryptographically secure manner in the cookie itself. Okay, for instance, you have an expiration date, and then you have the actual content of the cookie, and then you protect that with a digest, a keyed hash that contains the expiration date and the value. And that means that any attempt to tamper with the expiration date, or indeed with the value, will be caught by the server, because the server can simply check whether the hash still matches the contents and still matches the expiration date. Okay. So if we want to attack authentication, there are three main classes of attacks. There's the eavesdropping of the connections, so where you actually see credentials and authenticators sent out in the clear. You can eavesdrop, sniff the network traffic, and obtain them. Very simple attack, kind of attack. Another really simple attack is to brute force or guess the credentials or authenticators. And then there is a potentially more interesting class of attacks where we bypass the authentication by means of, using weak password recovery schemes, or what is indicated on this slide, session fixation, or SQL injection or SQL injection, depends on who you talk to. And we're going to look at all three in turn, but first we're going to look at the simplest one, the top one, the eavesdropping. And the example I'm going to give is from, ironically, a security And it's it's an old example. So, they probably wouldn't do that today. On the other hand, who knows? But anyway, so there was the RAID conference, which is a well-known security conference. And what happens there is that people submit papers to be published. And this is a very sensitive issue because you don't want your years of research, the paper that you've written, to leak into the world before it actually got published, because then people could steal your work. Okay, so people review these papers in confidence, right? So this is all a confidential process. And they use a web-based reviewing system for this, typically known as Hotcrap, for instance. Okay. But it might be something else. Anyway, in this particular case, in 2005, the websites that they used a very basic, literally HTTP basic authentication, which, as we saw earlier, contains, in the clear, although it's base 64 encoded, the username and password. So you would see this, but this is what it would contain. The username and password of the chair of the conference. So anybody who would eavesdrop on this connection would actually be able to obtain the username and password of that of the chair of the conference, and then access all of the papers that were submitted there. Super bad. Now, this is part of the HTTP basic authentication exchange. It could also be the user and password that is submitted through a form, or an authenticator that is included as a cookie, a URL parameter, or some hidden field in a form. All of these cases are, if they're not sent over a secure connection, are sniffable by attackers. For cookies, at least, you can set the secure flag, and you should set the secure flag, which forces the cookies to be sent, so they will not be sent unless this is a secure connection, an SSL connection. You should always do that for security sensitive cookies. Okay, now that was the most simple attack, right? You're just sniffing the network. The other really simple attack is to brute force these credentials and authenticators. And you can do that if the authenticators, for instance, have a limited value domain, say a 4-digit PIN. You don't need a lot of guesses to crack a 4-digit PIN. And moreover, you can use the fact that lockout policies, unlike in your, I don't know, a local ATM or terminal or so, lockout policies are much harder to enforce on the web, okay, for individual users. Another thing that you can use is the fact that sometimes authenticators are chosen in a non-random way, right? So something that is predictable. I said authenticators should not be predictable. Well, if it's a sequential session ID, it's easily predictable. If it's a user-specified password, it's often also guessable. Okay, so users are not very good at picking very strong, non-guessable passwords. Or sometimes it's predictable even if it doesn't seem to be predictable. And here's an example of a website, foobar, where we interact with the website using something that looks very random and non-guessable, until you realize the context. And the context is that this was observed at 3 on November 20th, 2018, right? 2018, November 20th, 3. So clearly, this is not chosen in a random way, and it's guessable. And like I said, and I want to emphasize this again, if you make your authenticators long-lived, you make it more likely that they will be cracked, and you make it also you prolong the time in which they can be abused. Okay. Now, the last class of attacks were about bypassing authentication. And there are a number of, in this case, we discussed 3 main classes of attacks, and one of them we'll discuss in a separate video. We'll talk about weak password recovery schemes first. Then we'll talk about session fixation, which forces the user's session ID to a known value. And finally, we're going to talk about form-based authentication, for instance, using SQL injections. to attack them. But first, let's go to the weak password recovery procedures. And often, sometimes they are weak because you can use them to reset a victim's password to a known value, and then as an attacker, you can use that known password and do things on behalf of the client. But what we're going to look at is a slightly different weak password recovery procedure that was active here at the Vrije Universiteit a couple of years ago, and it was used for everything, students and the employees, and everything at the universities is handled by this thing called VUNet. Okay, and if you're on VUNet and you forgot your password, which of course happens all the time, you go to the identity manager at a particular machine and you enter your VUNet ID and then you continue. Now, what does that mean? Well, what you have to do is, besides provide your VUNet ID, you also have to answer a couple of security questions. We know all these security questions. You've seen them on many sites, I guess. Things like, what is your place of birth? What is your favorite holiday destination? Name of your grandfather, grandmother, favorite singer, your secondary school, all of these things. But now here's the problem, right? So of all of these things, you only had to get this one correct and one more. You had to get 2 answers correct, and only the place of birth was mandatory. Of all the other questions, you only had to get 1, right? And moreover, some of these questions, if you think about it, right, your place of birth, a university in Amsterdam, I don't know, I think quite a few of the students and employees will be coming from Amsterdam or the big cities around them, right? That's not a lot of guesses that you need for that. Moreover, even if you know someone really superficially or Google somebody, it's typically really easy to find out where they went to school. Okay, so that one is easy to guess. And maybe some of the others, such as favorite actors and actresses, there's not a billion choices that you have to go through, right? There's probably just for most people a handful of choices. Actually a few dozens that you have to cycle through. Same with the favorite performers, singers, or bands. Okay, so easy to guess. But that was not the end of it, because after you guessed this correctly, right, at least one more, so 2 of these answers correctly, you could immediately specify a new password on this form. Okay. And with that password, you had access to the system immediately, and you could do whatever you wanted, including, change the password again or change the secondary email address. In the background, a notification would be sent to the already registered secondary email address to inform the user that, look, your password has changed and I'm hoping this is all okay and this is your new password. But by that time, it's too late, right? Because the attacker already has access to your account and could change the email address that was registered and the password and everything else. That's kind of bad. And but I should emphasize that the administrators at the time solved this very, very swiftly. So they were very good. They immediately accepted the problem. This was found by a student of VUSec, and they fixed it very quickly in an emergency update. And rightly so, because this was quite serious. It wasn't just the students that were at risk, which is bad enough, but it was also the employees that were at risk. And part of the administration of the employees contained the bank account number where the salaries were transferred. So imagine you do this massively for as many employees as you can on the day that the salaries are paid out at the end of the month. Okay, and change all the bank account numbers to an attacker's bank account number. That would actually be a very serious incident. And so they fix this very, very quickly. So now that we've looked at the first problem on our bypassing authentication list, the weak password recovery procedure, let's move to the second item on our list, which is session fixation. And with session fixation, we force the user to use a session ID that you determine as an attacker. For instance, by getting the user to click on a link which contains that session ID embedded as a parameter. And this could be a fixed value, or it could be something that you obtain as an attacker. And that's the example that we're going to see soon. But first, let's have a look at what OWASP writes about session fixation. And OWASP says this is an attack that permits an attacker to hijack a valid user session. Now, the valid user session, you have to remember, could be a valid user session that the attacker initiated, but it's still valid. So and let's move on. The attack explores a limitation in the way the web application manages the session ID. What is that limitation? Well, the limitation is that when you authenticate a user, you do not assign a new session ID. And therefore, you make it possible to reuse an existing one. That is a problem. And that's really important because this also provides the solution, the way to solve this, right? So if you design a web application from now on, you will not make this mistake. You will make sure that every time you assign a new session ID and prevent the reuse of existing one. Okay, so the attack consists of obtaining a valid session ID, for instance, by attacking with the server as an attacker, and then getting the user to use the link that you create, which contains that session ID. Let's have a look at a graphic illustration. So we have an attacker that wants to get access to the bank details and maybe the money of a victim, but of course the attacker doesn't have the credentials of the victim. Okay? But it doesn't need them if the application is vulnerable to session fixation. So in this case, the attacker sets up a login session with the bank and obtains a session ID, a valid session ID 55181. Okay, and since this application is vulnerable to session fixation, what the attacker will now do is send this as a link to the victim and says, look, what you really should check out is how the bank handles this, new thing. Maybe they're giving out free money. Check, what the bankofamerica.com is doing, or whatever your bank might be. Okay, and the session ID is embedded in the URL. So if the attacker uses that session ID and logs in with this URL, the bank will ask the user to authenticate with the username and password. And sure enough, the victim does this, username, password, and the same session ID still. So the attacker never gets hold of the credentials, but the session ID is now valid. Okay. And from that moment onward, the attacker can use that session ID to interact with the sensitive information on the server side. Session fixation.